All right, so continuing on the series of vector databases. My friend Leo Mayarovich and I wrote this kind of overview of the vector database space, which I was surprised how many people read that post and kind of gave us feedback. But anyway, so today we have another major vector database group that I'm going to talk with. So I have Frank Liu, who is Director of Operations and ML Architect at Zilliz. So they're famous for Milvus, which is a popular vector database. So Frank, welcome to the Data Exchange Podcast.
Thanks for having me on, Ben.
All right, so let me start by quoting to you. I like to do this, by the way, quote to you the how you describe yourself on your website. Right? So Zilliz, vector database for enterprise-grade AI, data infrastructure for AI made easy and powered by Milvus, the world's most popular vector database. So Frank, so we'll go through the system Milvus, particularly the Milvus 2.0 in this episode, but let's do some just basic baseline for the audience. So Milvus, in terms of data types, what's roughly the breakdown for you, as far as you can tell, how people use Milvus? Is it mostly text, mostly images?
Ooh, so I think for Milvus, so Milvus is open source, and we have so many enterprise users that I think it's hard for me to break down specifically, in each particular case, text, images, video, and, NLP, CV. But I will say that I think sort of three of our biggest use cases is for video analysis being one of them. Wow. The second is actually just recommender systems in general, so product recommendation, UGC recommendation, and the third is actually personalized search. Personalized search and text search, I think, is a part of that as well. But we've also done personalized search for a lot of other applications as well. A lot of non-machine learning ones where you can actually take these very, very generic pieces of unstructured data, turn them into vectors, and index them in a vector database, such as Milvus.
So another kind of baseline setting question is, so who's the typical user? Is it developer? Is it ML team, ML engineer, data scientist? Who is using Milvus?
Oh, I think generally, I would say for Milvus, there's such a wide range of users as well. But for the most part, most of the folks that we get in touch with are actually interested in deploying a piece of infrastructure for vector search. So we have folks who have played around with Milvus as a standalone system just on their own personal laptop or on a personal computer. But I think by and large, most of the folks that we interact with are actually entire teams, and they're interested in deploying their own vector database solution. They want to have vector search easy, they want to have it fast, and then we really go and help them deploy that as a key piece of infrastructure for their application.
So at what point do they normally turn to Milvus? So in other words, in the beginning, you have a bunch of embeddings, let's try to do it ourselves, and then maybe get a library like Face. And so at what point, is it volume and scale that makes them gravitate towards Milvus? So what is that tipping point?
Yeah, that's a great question, actually. Volume and scale are two of the components there, but also we actually have a lot of users where maybe they only have 10,000 or 100,000 vectors and they decide to use Milvus anyway. And a key reason for that is because there are a lot of database features in Milvus that you wouldn't normally see in a vector search library. So, we provide a consistent interface. We have multiple different SDKs that you can use. We have Java, Go, Node, Python, a lot of the common programming languages. And on top of that, there's also aspects of replication, failover, scalability, these things that you'd want to have in a traditional database, relational database or NoSQL database. And those are a part of Milvus as well. So I think, a lot of folks, and I'm really glad that you asked that question, because a lot of folks, when they look at Milvus, they say, oh, that's just vector search, maybe on steroids, right? But really, the point of a vector database, yes, vector search is a key component, but database is also a very important component as well, right? You want folks to have something that's very easy to use, something that has all of those database features that everybody knows and loves.
So here's actually an interesting demographic question, because you gave me an opening. So in terms of the SDKs and programming language, so what's the top two?
Oh, wow, that is a great question. I would say Python is top one. Python is definitely number one, and then.
So these are ML people. They're ML people then, right?
Well, here's the thing about vector databases, which is that a lot of the use cases behind vector search for the time being comes from machine learning. You have these machine learning models, and embeddings are a very, very core part of them, right? Some people, I think maybe like 5 or 10 years ago, folks would say that embeddings are a byproduct of machine learning models.
By the way, Frank, now, if I'm just a developer, right? So, and someone asks me, hey, Ben, now can you revamp our search? And I Google around, will I automatically land on embeddings at this point? Will that be the canonical thing to try for a developer? Or does it still require some savvy and kind of advanced knowledge and exposure?
Sure. Wow, that's actually a pretty loaded question. So here's the thing, which is that if you are trying to do, I think the future of search is going to be semantic search.
Right.
So, an example.
I guess my question is, it's the future here.
The future here. Okay, fair enough. I think the future is here today already, right? I think folks are moving in the direction of semantic search. I think just last month I saw, a blog post from AWS where they also have, as a part of their open search solution, they also have now vector search on there as well. So they have KNN search. And when it comes to using embeddings, right, and especially when it comes to using a wide variety of different ML models and training your own, I think that is more accessible today than ever before, right? You have all these different libraries which are meant to help you generate embeddings. You have these different platforms, Cohere, OpenAI, making a huge push towards embeddings as well. Jan LeCun, at some point a while ago said that we should just embed everything. And I think embeddings today are actually fairly ubiquitous. I read a lot of blog posts. I talk to a lot of other folks in the industry, and they say, oh yeah, embeddings, we're actually using that internally. And everybody has this internal.
Yeah. That's when we wrote our post, basically, we had a phrase in there, which is basically, vector database is basically what happens when you embed your database. So when everything is an embedding, right? So, and then I guess as you're talking there, it dawned on me, I actually don't know the history of Milvus. Can you give us a brief overview of how Milvus came about?
Sure. Yeah. So actually, Zilliz, at the very beginning, we had, we were working on this database technology, and there are actually a lot of folks who, came and said, hey, I actually have a lot of vectors that I want to store. I want to be able to search across them. And this was actually probably way back in the early days, 2017, 2018. And that's really how we got started creating Milvus. That's how Milvus was born, really.
Oh, I see. So it was actually from the ground, from the people that.
Yeah.
So it's not like you guys started out with a vector library and then built a database on top of it and then formed a company. No, you already had a company, and then. Is that?
Yeah, and it was really based around a major need for vector search, right? And for vector search, for storage, indexing, large scale vector search solution. Well, I want to say vector search has been around for quite a long time already. If we go back into the early days, well, I say early days, but this is really only like before deep learning. Folks were using these feature vectors as well. SIFT, surf,
Right. Sift,
what are some
hog.
Hog, yeah.
Yeah.
And this requires a vector search, right? The first prog quantization paper, not the first, the prog quantization paper I think came out in 2010. Very common form, combining prog quantization with IVF is actually a very, very common form of vector search. And that came out before, the AlexNet paper, before computer vision went through this whole deep learning, hype cycle. So vector search has been around for a long time. And, I think the need, since 2012, 2013 became even greater. Back when I was at Yahoo and we had a ton of data then, we were doing this similarity search across images, but there was never a vector database solution. And there was some really complicated stuff.
But it seems like that general primitive has persisted, right? Which is similarity search, nearest neighbors. Now you have a bunch of ANN algorithms. By the way, so generally when we say vector database, and obviously there's not a universal definition because there's many different providers and open source projects, right? So, but generally, here in my mind, I have to have the embeddings, so they're not going to help me generate the embeddings, right? So then I load it into this vector database, and then this vector database, some of them have actual databasey features like you described, and some don't. But they all have libraries of similarity search somehow, right? And then they all have they all target information retrieval and search for the most part.
Yeah, no, absolutely. Yeah. Semantic search, I would say.
Right. But then when you say that, there's all these natural kind of follow-on applications, like you said, recommenders, maybe even Q&A systems, right? But generally, how do people interact with these systems? What is the SQL for vector databases?
Yeah, great question. So for a vector database, vector databases don't have traditional SQL or like a traditional query language.
And there's also different data types, right? So
absolutely, yeah. And there's different data types, but all these different types of data are represented using vectors. So what's in the database is vectors, and of course their vector IDs and maybe a bit of metadata as well.
And if you interact, if search is kind of your way of interacting, usually that means typing something, or in the case of image search, showing an example.
Yeah.
Right.
Yeah. So I mean, we can. I think a fairly common use case, that most folks know about is semantic text search, right? The idea that if I want to search for, I always really like this example. If I want to search for, computer science, electrical engineering and computer science are two very, very related fields, right? And a properly trained machine learning model would output embeddings that reflect that. Whereas, if I just went with traditional text search based off of, labels or, these strings, I probably would say, if I search for computer science, maybe some articles about social science would come up or biological sciences, right? And these are actually...
Well, first of all, you probably even have to quote the computer science, right?
Yeah, exactly. And you end up having, there are limitations to traditional search, right? And I think when it comes to text, I think it's much easier to understand why we need semantic search and why we need vector databases.
So you folks published this paper, VLDB paper on Milvus 2.0, which you call Manu. By the way, I think you should keep the name Milvus since everyone knows what Milvus is. Why rename it? Right. So are you going to rename it?
No, we're not going to rename it.
Okay. It's just a code name. It's just like a project name.
Yeah, and we wanted so Manu just to keep it entirely clear. Manu is Milvus. Manu is Milvus 2.0, but the reason we wanted to give it a new fresh name is to reflect the idea that this is a
Completely new system.
It's cloud native. It's really reimagining what it means to be a vector database, right? It's still
Manu. So we'll refer to Milvus 2.0 as Manu to distinguish it from Milvus. So Manu right now is what? Is it just kind of you guys described it in a paper, but what is the availability of it as far as open source or hosted?
Yeah, so Manu is actually available. Manu is what is there in the Milvus repository right now. That is Manu. We just decided to give it this particular name to help distinguish it, to help folks realize that this is a reimagining of what a vector database is. But Manu is available for anybody to try.
So you consider it so someone who will use Milvus now, go straight to Manu. Don't bother with Milvus 1.0.
Yeah, I would say go for Milvus 2.0. And 2.0 has all the features of 1.0 plus a lot of plus many of the other ones that I mentioned that you would want from a traditional database as well.
So let me just go through quickly some of the highlights from this paper, learnings from this paper, right? First one, support for complex transactions is not necessary, which makes sense. So by the way, so in the traditional database world, usually the division is between OLAP and OLTP, yep. But this is kind of a different animal, right? So
absolutely.
So where does this fall in the OLAP OLTP? So you don't really use vector databases to run reports, do you?
You don't really use vector database to run reports.
So it's not OLAP. We can say it's not OLAP, right? So, and then OLTP means to support some application, you're writing, you have these transactions and stuff. It's not that either, right?
Yeah, I wouldn't really group it. I wouldn't really say it's that.
So it's like it's like under search, basically. It's the main workload is search. It's not OLTP or OLAP. So it's a different thing. So, yep. So clearly this statement is true then. Support for complex transactions is not necessary. All right. So then the second statement, a tunable performance consistency trade-off. So this is the basically how strongly consistent it is or eventually consistent it is.
Yep.
Right. So, and again, I guess I go back to my earlier observation, which is basically for a lot of these things, I guess my impression, and this is probably completely wrong, is it's more batch in the sense that here's a batch of text, vectorize them, and then load them into the database, which is clearly not true because these things are being used for real-time search, right? So somehow there's some kind of notion of, am I getting the freshest vectors and things like that? So there has to be some notion of consistency in these systems as well, right?
Absolutely. Yeah. And when we say tunable performance consistency trade-off, I think that simply means that instead of saying instead of supporting either strong consistency or eventual consistency, we are able to tune based on your particular application or based on the application that the user is trying to develop. We're able to tune it based on their particular needs. Obviously, there will be differences in performance, but that's one of the things that we're able to do, right? You look at a lot of examples out there of use cases of vector databases. I'll give an example. If I have, let's say, if I'm doing product recommendation and I use a vector database to index all of the images, if I put a new product, it probably doesn't really need to appear in search results immediately. If there's, let's say, a 5 to 10-second delay, maybe even a minute-long delay, that's totally fine, right? And we can tune the database that way to improve performance, rather than saying, okay, we must have, we must support strong, it has to be very, very, this result has to come immediately, right?
And so then the freshness of the search results has to do with how quickly you can vectorize the underlying data and load it into the database, right?
Yeah. I think I think that's definitely simplifying things a bit, but yeah, more so, yeah.
And so to what extent, so in your case, to what extent do you help the user or developer with, if they really want to have kind of this notion of real-time search? Do you have the tools to make that happen?
To make search truly real time?
Yeah. I mean, basically, that means basically having, if I add new text to my corpus, then you guys index and boom, right? So, and then it starts showing up if it needs to show up based on relevance, right? So.
Yeah, no, absolutely. I think there are different knobs that you can tune within Milvus 2.0 to actually make that a possibility.
And so a developer who uses Milvus basically doesn't have, basically search becomes a much, much easier application to build.
Absolutely.
Right? Yeah. So, by the way, Frank, vector database and graph database and vector database and time series database, I think I get the impression that it's one of these are things where a hacker or engineer will go, I can build this myself, and then they start building it, and then they can build something, but it doesn't. At some point, it just becomes hard to scale and provide all of these additional features, right?
Yeah, absolutely. And if you're looking at specifically at a database, you look at Moore's law, and the future is definitely distributed. And I think I would wager to say that building a single instance vector database, something that's just meant to run on a single computer, run there, just sit there, I think that is. That's tough, but that can be done by a team within a pretty fixed period of time. But once you want to take something compute heavy, that requires a lot of once you want to take a compute heavy database and scale that, that becomes very challenging.
By the way, when we looked at the different systems in the space. And actually, what I did was I created this graphic where I took quotes from how these systems were describing what they were working on. And the one thing that stood out is a lot of people were talking about scale and scaling. So it seems like this is something that all these systems are working on right now. And the impression I get is it's easy to handle in the millions. Few millions of vectors, and then it becomes harder because I think, for the most part, I think a lot of these systems put these embeddings in memory, right? Yeah.
There's a approximate nearest neighbor search solutions that actually allow you to put vectors in disk. Specifically in SSDs, taking advantage of the structure, the internal workings of an SSD. But for the most part, these vectors are actually stored in RAM.
Right. And so then, if you're comfortable saying, so what is the largest known instance deployment of Milvus in the wild? In terms of
we've had deployments of 800 million. I'd have to double check, but I'm pretty sure we've had deployments in over a billion as well, over a billion vectors. And that I think, yeah, definitely. I'm definitely willing to say that that's probably one of the largest deployments that, for any vector database, not just
outside of big tech,
what's that?
outside of the big tech companies, right? So
Yeah, and I think the use cases for vector databases are so numerous that they really permeate into many different industries.
right. No, but I mean the big tech companies probably have deployments that are massive, right?
Absolutely. Yeah. But I would say, there's a quick note that I want to add on there, which is that they probably have these vector search solutions. They might have a vector search backend or, something that allows them to do large scale ANN search. But I would say that, probably these are either many disjoint systems or it could be one monolithic system that doesn't really necessarily qualify as being a database. Maybe there's, maybe it has some interface challenges, or it has, some other
ops and systems, right? So,
exactly, exactly, or a very ops heavy system. And that's really a reason why you see, why, for example, a lot of these big tech companies haven't really made their, provided their own vector search solution to the masses.
Right. So when you're talking 800 million, a billion vectors, so how big a cluster would that be for a vector database?
For us, I won't really say how big of a cluster 800 million is specifically. It depends a lot on the vectors themselves, right? So you could have 800 million, let's say 64 96D vectors, and that would be very, very different from 800 million, 4096.
Oh, so let me rephrase my question. So what is the biggest known Milvus cluster?
Oh, wow.
You don't have to give the exact number, just, is it 100,000 in the thousands, right? So, of nodes?
That is a great question, actually. I'm going to, the biggest known deployment. I'm probably gonna have to get back to you. I'm probably gonna have to get back to you on that. But I do want to say that we have tested Milvus internally, and we've been able to scale it, beyond 100 nodes fairly easily. But definitely, I would say that's probably not the biggest deployment of Milvus 2.0 or of Manu. But again, I don't want to put like a very exact number or even a range on it. I'd have to double check with the team and get back to you.
Right. And so then, as you say, the future is distributed, but also the future is heterogeneous, right? So,
absolutely.
So, because you might be using CPUs, different GPUs, different ASIC, right? So, and it seems like this is something you folks address and basically make that problem go away for developers.
Yeah. So if you have a GPU and you do decide to allow Milvus to use the GPUs within your, let's say, your query nodes, we will take full advantage of that. And later on, we plan to support other of these sort of computing accelerators, FPGAs, TPUs, NPUs as well.
So let me give you a chance to define the minimum features of an enterprise grade vector database, and here you can obviously rattle off features that you have. So first of all, I would say it has to be able to easily distributed, right? So supports heterogeneous hardware, fault tolerant. So in terms of databases, so what kind of databasey features would it need to have in terms of security, privacy, access control? So all of those are required as well in your mind.
Yeah, absolutely. And you'd also want a caching layer as well. So if you do the same query or if you do very similar queries repetitively, you want those to be returned fairly quickly. Especially for a real-time solution. You mentioned access control. I think that's a big one for traditional databases and also for vector databases as well, right? And you also want high uptime. So you want high availability, and this is, again, all of these features are things that you wouldn't really see in just a vector search or vector indexing library, like let's say like the
Face.
proposition, like Face. Huge shout out to Face as well. Milvus actually uses Face as one of the core indexers. That's not to throw shade on Face at all, but I think it's a different problem, right? I think it's what Face is trying to solve versus what we're trying to solve is to make something that is very, very, try to take vector search and make it universal.
So what about Frank, the ANN models? So who owns that? Is that something that you just assume the vector database provides for you, or do you assume that you will have to occasionally tweak it or modify it, or what generally happens to the ANN component?
Yeah, so are you referring to the models or are you referring to the ANN algorithms?
So the models themselves, so do developers just basically assume that that's taken care of by Milvus, or do they want some control over the models and, in other words, occasionally tweak or maybe even bring their own models?
So usually when it comes to Milvus, we let the application developers or we let the users bring their own models, or even in some situations, bring their own handcrafted algorithms, which I won't get too much into. But the idea, you mentioned at the very beginning.
But then, what about the developers who don't know much about ANN? So you must provide some minimum capability there, right?
Yeah. So we have a sister project to Milvus called Tohi, and Tohi is all about turning a wide variety of unstructured data, so images, video, audio, text, 3D molecules, into vectors. And this we provide just a lot of pre-trained models within Tohi. It's a much newer project, to be clear. So it's not as mature as Milvus is, but that's one of the options that users have.
So it sounds like that project is more about taking raw data and vectorizing.
Correct.
So I'm more concerned about actually the models that give me the results of a query.
Oh, okay. I
So
see
is
what
that is that something that you must provide some of those, but then the question is, do people also want to be able to bring their own and modify it, so pluggable kind of,
bring their own ANN algorithm, right?
Yeah.
Great question. Okay, now that makes sense. So so first off, and I'll sort of answer this question in two parts. All right, so first off, we do have a lot of different ANN methods right out of the box that folks can choose from, right? A lot of the ones that are in Face, IVF, PQ, but we also support graph-based and tree-based ANN algorithms as well, Annoy, HNSW.
Yeah.
And the second part of that question is, if a user really has their own ANN algorithm that they want to bring on board, there's a component in Milvus called Nowhere. We're pretty big MCU fans here. But Nowhere is, it's meant to serve as the core indexer within Milvus. So Nowhere can be extended to support other ANN indexes as well, right? And that's one of the unique features of Milvus, is really, there is this sort of bring your own ANN algorithm type of type of idea going on there.
So it sounds like it appeals to people of varying expertise, right?
Yeah, absolutely. I can't say that we've had anybody want to bring their own ANN algorithm just yet. But maybe, who knows? Maybe soon.
Right? Yeah.
Nowhere.
So roughly, what is the difference between Milvus open source and the hosted Milvus by Zilliz?
Yeah. So Zilliz Cloud. So Zilliz Cloud is meant to. So yeah. So Zilliz Cloud is meant to be a fully managed version of Milvus, right? So we take away a lot of the infrastructure layer. We manage it directly for you. But on top of that as well, we also provide a lot of observability features as well. Later on, there's going to be, you'll be able to see what's going on inside of your vector database. You'll be able to visualize some of the indexes. So you'll be able to visualize HNS-W. You'll be able to visualize Annoy. You really dive deep into what's going on inside of Milvus, right? And I would say Zilliz Cloud is very much, the open core model. Where Milvus, if you want to use it, if you want to try it on your own machine, you're absolutely welcome to. But then there's this managed service as well that really abstracts away a lot of the operational aspect for you.
And basically, it's also obviously elastic, right? In terms of you can scale out as much as you want, both for the open source, but obviously it's much easier to do it in the hosted version because everything is taken care of.
Yeah, well, you can specify how many compute units that you want. And I think something pretty unique about our hosted version, about our hosted solution, is that we actually have what's called an index pool. So you don't really, the index pool is essentially just a pool of machines that, it can grow or shrink in size dynamically. And it's meant to just sit there and index data for, different types of users, for different users, basically.
So is there the notion, Frank, of data catalog and data governance for vector databases?
I would say so here's the thing about vector data, right? When it comes to data governance, let's say for some particular reason, I have access to whatever vectors are in a vector database. It's hard for me to, I would say not hard, it's impossible for me to take a vector and go back to the original data, right? I wouldn't be able to, let's say, reconstruct an image from a vector, especially if I don't know what the original model or algorithm that was used to generate that vector is. But with that being said, that doesn't mean that we don't take data governance seriously, and that doesn't mean that we don't take access control seriously. For a vector database such as Milvus, and I imagine for a lot of other vector databases as well, open and closed source, we want to make sure that data is always secure, both for the open source version and especially for the managed service as well.
And, in the data warehousing world right now, data lakehouse and all these things, catalogs are just knowing what you have at a high level. I'm assuming that's something that the vector database people will have to also provide at some point, right?
Absolutely. Absolutely. Data catalogs, I think it's, a lot of these, if you look at Snowflake or if you look at Databricks or if you look at a lot of traditional, RDMS, there's always there's what they do, I think, for structured data or for document data, JSON documents or wide column stores. We want to try to do that for unstructured data, right? So, again, things like images, things like audio, things like geospatial data. These are all examples of unstructured data, and it's simply a different data domain. I think that's really what vector databases are there for.
So one of the things we point out we speculated in the post is at what point do some of these more general systems start co-opting vector databases? Because the idea here is that the platform and infrastructure teams, they want to have fewer systems if possible, right? So if you can take a more general system like a lakehouse or Elastic and create vector indices, maybe you can get by. So over the long run, I'm sure you will feel otherwise. Over the long run, will vector databases be kind of completely separate categories for IT teams, right? So, or will some of that functionality be rolled into, like Elastic or a Lakehouse? I guess the main thing is that maybe the use cases are different enough, the data is different enough that it may still warrant a specialized system, but the jury is still out, I think, over the long run. It depends on how well and how quickly these existing systems are able to co-opt some of these features, right? So
yeah, absolutely. So you mentioned Elastic, right? And Elastic actually already has their own KNN search endpoint. I think they just call it
it's
KNN.
actually the Elastic actually is the most popular vector database just because I
am going to disagree with you on that one. Elastic is more for traditional search. I think it was in
by popular I mean it's something that people will check out and try right away. I'm not saying that it's what they end up using, but just because, right? So they're familiar with Elastic, right? So
yeah, and I think Elastic has a particular feature, and I think they've made quite a few announcements about it, but I think the thing about Elastic and the folks that I've spoken to, and they give me very similar feedback. I think the thing about Elastic is that it's not really architected from the ground up to store vectors. It's more
Lucene and JVM, right?
Yeah. So again, it is based originally on Lucene. And it's more, I would say it's more for a lot of the traditional text search. And don't get me wrong, I think there's still a lot of value in that, but I'm not really going to use the word fails, but I think where it pales in comparison to vector databases is that vector databases they're meant specifically for vectors,
and also text search itself, man. Once you see the similarity search, it's just why bother? So I mean, for them to have a role, they would have to basically have a lot more of these vector database capabilities, I think. Yeah.
But the reason why Elastic has KNN search built and why they have their KNN search endpoint is because I think they see this as being very important for text search as well, right? And
right.
Again, I think a vector database is not just limited to text. It's limited to really any type of unstructured data.
Yeah. Like you point out, which actually is awesome, is you said one of your most interesting use cases involves video.
Yeah, absolutely.
Right. So, which means, so how exactly people index videos? Is it frame by frame?
So there are different ways to index video, but generally it's done segment by segment.
Okay.
There are also algorithms, there are also these models which will actually take an entire video and distill it into a single vector, which
that is insane.
That's insane. That doesn't really,
I would be surprised if that works, right? So
yeah, that's it works to a certain degree, right? But the problem with that is, you could have a video that's an hour long and another video that's a second long, and it's impossible to
and by the way, this reminds me of one of my favorite data types, which unfortunately is the one with the fewest tools, which is audio, right? So and audio is the same, because you can have a podcast which is an hour and a half long, and then you have like a 10-second snippet, right? So and then it's different encoding formats, different file formats, right? So yeah. And so but I think to me it seems like the future is clear, that these, because once you use these embeddings, they're almost like magical. You know, in terms of why bother going back to pre-embedding world, right?
Yeah, yeah. I hesitate to say pre-embedding. I think there's a lot of use cases where you need,
What
these.
bag of words?
Oh, yeah, if you talk about, I think you talk purely about text. Yeah, I think we're a bit beyond bag of words.
Yeah.
But I see, I see in the future these sort of like these document databases or these tabular databases, relational databases and vector databases really working together. And a lot of people ask, okay, our vector database is sort of like a niche database, kind of like a time series database, or a columnar data, or graph database. And my answer there, obviously, I'm biased, but my answer there is for now, yes, maybe. But
Yes.
I
Yeah.
think
Yeah.
if 2 or 3 years in the future,
Yeah.
I
Yeah.
think,
Because embeddings will just grow in importance, right?
yeah,
So you will have to
absolutely.
have a strategy as an IT or engineering organization. What's our strategy for embeddings? Well, let's
Precisely.
just compute them and put them in the file system. Well, that's good. That's good in the beginning, but that's not a good strategy.
Yeah.
Uh,
Good
uh,
luck once you go into the millions.
yeah. Overall, right? So I think at some point it just becomes something you will need to approach more systematically. By the way, Frank, one question around this space. Um, what is the so? I'm sure you get this question, right? So, feature stores versus vector databases.
Mm.
So, but feature stores are completely different in some ways. I mean, sure, some features are embeddings, right? So, but do you still have to explain the difference between these two things? And by the way, you might as well explain the difference between these two things as you answer my question.
Yeah. No, that's a great question. So when it comes to a feature store versus a vector database, generally, for most folks, I don't really see a major confusion there. The
Right.
thing about vector databases is that vector search itself is so ubiquitous that really it's all about getting past, it's really all about associating a vector database with vector search at large scale.
So,
And
by the way, the one thing that feature stores do well that I don't know how well the vector databases do or whether they care about it is versioning, right? Lineage and versioning.
yeah. In a vector database, you can store, there's metadata that you can store with each collection. But a feature store, I think, is less of, and I always hesitate to say this, but I think a feature store is less of this very, very hardcore, data infrastructure and more of a way to do feature sharing and a way to do a lot of automation for the.
And feature sharing and serving, basically, right?
Yep, exactly. And a vector database is meant to, I think most of the folks that I talk to, there's really not too much confusion between a feature store and a vector database, and more questions I think are along the lines of, okay, what exactly is a feature store? I think a vector database is a little bit easier to explain than what a feature store is, right? I think curating these features for machine learning and doing a lot of this versioning, doing a lot of pipelining, this is actually a little bit different from what a vector database is there for.
So when I talk to vector database people, so it's basically while the conversation is around vector database, but hanging in the background is always vector search, right? So,
Yeah.
but then once I have a database of embeddings, surely I can use that for more than search. So, for example, I do a lot of things in NLP. Well, in NLP now, what's the first thing you do? Well, I have to calculate the embeddings, right? And store it somewhere. Well, what if the embeddings have already been calculated by someone and I just talk to a database? Then I don't have to do that, right? So it seems like there might be, because embeddings are important for more than just search, that vector databases can be kind of the central place at some point where people go to to get started on their ML pipeline, for example, right? So which involves using embeddings. But right now, all you folks assume that I'm only interested in search.
Yeah, well, search, storage, and indexing, I think, is a very hard part, right?
Yeah.
It's a hard part, and I don't want to, if I'm an ML engineer, or if I'm someone in DevOps, I don't want to mess with all these ANN algorithms. I don't want to. I have no clue. What Not that I don't have any clue, but vector search can be pretty complicated,
Right.
And especially vector search at scale. But
you call it, you folks call it a vector database. So implicit there is that you're collecting all of the embeddings. Yep. But then for people who are generally using embeddings, why not provide them with interfaces so that they can just grab the embeddings from the vector database, even though they're not maybe working on search, right? So,
yeah, and you absolutely can do that for a vector database as well. So you can just grab if you have a particular element that is in the vector database, you can grab that, right? Storage is obviously a key part of a vector database as well, but storage is not really the challenging part, I would say. Again, the challenging part is search. Later on, when it comes to a vector database, I think it's important to talk about the ecosystem. And the ecosystem includes everything from observability to upstream embedding generation as well. How do I take this data and automatically generate the embeddings for it, right? Maybe that way my future interface to a vector database might not necessarily be these individual vectors, but I could search for, let's say, an image and a piece of text. I could hit the vector database there, and I would be able to return a variety of different types of data.
Actually, one thing that just occurred to me is let's say I have a raw data, unstructured data, text, video, images, right? I calculate the embeddings. I store it in Milvus. But then now I want Milvus to do something for me, which is what? One, tell me the duplicates, tell me the clusters. So basically do some kind of exploratory data analysis, kind of review the data for data quality, right? So like, for example, before I build the machine learning model, I want to make sure that the labels are correct, right? So
yeah, no, absolutely.
Because this image is, this thing is labeled a cat. Bring me all of the images that have been labeled cats, and then, these aren't cats.
Yeah. Yeah, I'm totally with you on that one. I think, we say vector search and search, but the reality of it is that vectors are, search, I think, is just a primary challenging problem.
The first use case, the first major use case.
Yeah, I would say, vector search as this algorithm, as a component of a vector database, allows a vector database early on to target lots and lots of different applications, lots of industries, lots of use cases. But later on, some of the applications that you were just talking about, Ben, absolutely, those will be targeted as well. And
it becomes basically, if vectors are the lingua franca of ML and AI, I put all my vectors in this thing, and then now I'm a ML team. I'm supposed to build the model. Okay, let's grab all of the data from the vector database. Let's do some data quality checks first, and then build the model, and then stick it back with some kind of metadata so that we know versions and things like this. So you can see more and more capabilities around it, right? So, and maybe you can even run reports around your raw data, right?
Yeah, it's possible. I think, certainly for vector databases, if you're talking about machine learning, usually a production-ready model is a part of that pipeline or is a part of that application. But I think certainly down the road, we'll be able to see way more, I'll call them like advanced use cases or different use cases, different features in a vector database. Once we get to Milvus 3, Milvus 4, we're going to continue to reimagine everything that's going on. In the
But as many people pointed out, of course, search and information retrieval just so many use cases and that you can
Absolutely.
justify right off the bat, right? So
Absolutely. Absolutely. And it follows a very natural querying paradigm as well, right? You know, similar to a SQL query, but now instead of a SQL query, you have a vector query.
all right. So in closing, you folks wrote this VLDB paper to kind of describe Milvus 2.0. So
Yep.
what's on the roadmap in the next 6 to 12 months? Is it over? Is the project closed? Is no more features?
Absolutely not. Absolutely not. So as I mentioned, you know, we're going to continue building on top of Milvus 2.0. And in the future, there's going to be Milvus 3, Milvus 4, Milvus 5. And each of these, it's the vector database.
So what's the main priority? Let's say, for example, you address scaling. That's addressed. So what's the next priority?
Next priority, I think, you know, this heterogeneous computing, as you were mentioning, is another priority for us there. So extending GPU support. We also plan to have disk-based support very, very soon. And I think that's very, very unique to vector databases there. You can't really...
So what performance penalty do I pay for going to disk?
Actually, you know, if you are smart about it, I would say there's actually really not a major performance penalty. You will notice some, but it's definitely not, it's definitely much less than an order of magnitude. And again, I don't want to give any specific numbers out there because, you know, I'm going to say, oh, you know, it's you get like barely any performance loss, and someone's going to
So this is SSDs or actual disk?
Yep. SSD, not magnetic disk. Yeah, SSD. And really taking advantage of, you know, as I mentioned, really taking advantage of the structure of an SSD to make sort of indexing and to make these block sizes more palatable.
I think this is Vespa guys may already have that. Yeah.
Oh, Vespa has disk based, right?
SSD. Yeah, I think. Yeah. Cool. And so then that means even more scale without much performance penalty, right? So
at level.
Yeah. And so with that, thank you, Frank.
Yeah, thank you for having me on, Ben.